Lesson 118, number 20. Use an infinite geometric series to express this decimal as a common fraction. Okay, so infinite geometric series. We have a decimal with a repeater, and we're gonna express it as a fraction. So I think I remember how to do this. I know that however many digits repeat, R, hopefully you remember what R is. R is the common ratio. It's hard to hold this iPod. Only one digit is repeating, so R is going to be 10 to the negative 1. If two digits were repeating, R would be 10 to the negative 2. If three digits were repeating, R would be 10 to the negative 3. 10 to the negative 1, I like to write it as 0.1, so that's R. So I could really rewrite this as 0.42 plus 0.003 times R. Here, I wrote it up here. One repeater. So in other words, you just move the decimal one place to the left. If there was two repeaters, you'd move the decimal two places to the left. If there was three repeaters. So, or you can write it in kind of like, I don't know, exponential, like scientific notation style if you want. There's a formula. This is just a formula that they gave you for the sum of a geometric series. So it's a sum 1 over 1 minus r. So that's a formula that you just look for that in your book. So I need to know what a sub 1 is. I know r is 0.1. So 1 minus 0.1. Well, it turns out a sub 1 has to be the repeating number. So since it's in the thousandths place, it has to be 3 thousandths. Okay, and then just add that to my 0.42, and then just do the math. I just left it in decimals like this. But then I remember we got to get it into a fraction, so you can move this 3 places to the right, and then move this decimal 3 places to the right, and that will give you 3 over 900. This one, that's just 42 over 100. And then I multiplied this top and the bottom of this one by 9 to get it over 900. Then I realized that right there can be reduced, so I just used my calculator to reduce it, and I got 127 over 300, and that's the answer.